Welcome to the Museum of the Future exhibition hall. In this section, you will see the evolution of low-carbon building materials over the past century. We will introduce rammed earth materials, bamboo-based materials, and seaweed materials that were widely used in the past. A century ago, the global construction industry was mired in a severe materials crisis. At that time, the mainstream building material was concrete, whose production process consumed a large amount of global energy and released enormous amounts of carbon dioxide. People of that era, though aware of the urgency of climate change, were still bound by the inertia of industrialized construction. Meanwhile, an ancient plant, bamboo, is growing wildly all over some mountains, but its utilization rate is less than 30%, with most of it being used as firewood or discarded. Scientists at the time began to study whether this sustainable material could shoulder the responsibility of supporting modern civilization. The answer lies right before your eyes. It is a bamboo-based fiber composite material. Its density is 1.2 grams per cubic centimeter, its bending strength exceeds 350 megapascals, and its tensile strength exceeds 360 megapascals. These mechanical properties surpass those of many ordinary steels used at the time. The only drawback was that, due to insufficient production capacity at the time, the material was more expensive than ordinary steel. With the development of technology and the mass production of materials, its originally high price was also reduced, making it a true primary building material for humankind at that time. According to historical records, the photograph before us is the first modern building in human history whose main structure was entirely constructed of bamboo. Although its shortcomings can be seen from today's perspective, it still demonstrates a forward-thinking approach to materials. Emerging from the lightness and transparency of composite materials, we are about to enter a world of stability and solidity constructed from a new material. 30 years of development have made low carbon emissions an essential attribute of building materials. The foundation of the brick in front of you dates back to 2024 at the Center for Print Research at the University of the West of England. Instead of using entirely new chemical compounds, researcher Tavs Jorgensen and his team opted to reintroduce an ancient technique that has been used by humans for thousands of years: rammed earth. This is also because the high demand for bamboo materials provides a large amount of sustainable foundation for the construction of new rammed earth foundations. Researchers use computer-designed 3D printed molds to extrude unburnt clay mixed with natural fiber mixtures. Please take a closer look at the side of this brick. Can you see these intricate grooves? They are designed to completely eliminate the mortar that is indispensable in traditional construction. This means that the walls can be built quickly and precisely like building blocks, and when they are demolished in the future, each brick can be returned to the land intact without generating any construction waste. Also, take a look at the surface of the brick. These fibrous textures are not impurities, but rather they can further increase friction, giving the unfired clay bricks sufficient strength. When people focused their attention on terrestrial building materials, the strange changes from the ocean once again broke through the research bottleneck at the time. Please see the brick in the picture. In 2093, along the coastlines of Mexico, the Caribbean island nations, and even Brazil, it all began with an infestation of a brown algae called sargassum. As it rotted, it released foul-smelling gases, devastating tourism, killing marine life, and proving extremely costly to clean up. Against this backdrop, architects and startups around the world have begun to focus on the feasibility of marine building materials. A material solution called waste resource utilization became the focus of research at the time. Scientists in the laboratory actively drew on the experience of the previous generation of 3D printed rammed earth and used sargassum as the core material to create a new building material called Sargablock. Researchers mixed sargassum into ceramic clay at a ratio of 40%, which not only reduced the weight of the material, but more importantly, this material hardly damaged the soil, allowing more soil that was originally used for rammed earth construction to be used for food production. If you observe life closely, you'll find that this building material is often used in coastal buildings. Today, as we look around at smart cities made of various eco-friendly composite materials, it's easy to forget where this path began. These materials may not be strong or smooth enough, but they embody humanity's courage to escape the high carbon trap and move towards truly sustainable architecture. When humanity learns to view ecological issues from a systemic perspective, the garbage that once left us helpless will eventually become the foundation of our habitat. Please move to the next display case. Thank you for watching.